Hello, today our topic is CPU scheduling. So, we all know that CPU is the brain of the computer and we need CPU to execute all the process as fast as possible. So, for that to be done, we need to make sure that scheduling is done in an efficient manner. Okay, and scheduling is one of the basic function of an operating system. So we have to make sure that we have to utilize CPU to the maximum, and that can be obtained using your multi-programming. And we use n number of algorithms to schedule your CPU. They are called as your scheduling algorithms. So from your process cycle, we know that all the process will be at your ready queue, and a scheduler will select which process to send into the CPU. So generally there are two cycles. One is CPU burst cycle. So CPU burst cycle is nothing but the time where the process efficiently utilizes the CPU. And you have input output burst cycle. Okay, it means the if you have any call for to access any input output devices, again the CPU will send it back. Okay, and it will wait till the input output it has been accessed, and then again the process will come back to the CPU. So there are two types of cycle. In that, we have to make sure the CPU schedule is done properly when you have your burst cycle, that is when the process is efficiently utilizing your CPU. So we have single process system and multi-process system. In single process system, only one process can run in your CPU at a time. So all your process will be waiting in your ready queue. And short-term scheduler, your short-term scheduler will select which process to enter into the CPU. Okay, for that you have many performance criteria. And CPU scheduler, so this is this is the diagram of your process cycle. First a new process will be created and then it will be sent to the ready queue, and from ready queue your short term scheduler will select which process to go to your CPU, that is your running state. In between, if you get an interrupt or if you have an input output call, again it will go to the waiting stage and then it will go to your ready state. Okay, and again the scheduler will select when that process should come back inside your CPU. And once the process is over, your process will be terminated. So this is your process cycle. Okay, and you have two types of scheduling: preemptive and non-preemptive scheduling. Non-preemptive scheduling is when a process is running inside the CPU, no interrupt, no system call, nothing can come in between. Okay, it will not be stopped. Once a process enters the CPU, only after its completion it will terminate and the next process can come inside. So that is your non-preemptive scheduling. If you go for preemptive scheduling, even when one process is running, it can be stopped, it can be paused, and other process can enter. Okay, so that is your preemptive scheduling. So these are two types of schedulings. So we have many preemptive and non-preemptive algorithms which we'll discuss in the next coming topics. So when we use the non-preemptive algorithm, it is very simple. We don't have to worry about any other process entering, and we will not have any race condition. So these are the advantage. Disadvantages: it does not allow multi-programming. Okay, and advantage of preemptive scheduling algorithm is they allow for multi-programming, but it may end in race condition if it is not properly scheduled. Okay. Okay, so we have some scheduling criteria through which our scheduler will select the best process to enter inside the CPU. So the criteria are: first is the CPU utilization. We have to make sure the CPU is always busy. Okay, next your throughput. Okay, then that is the number of process which will complete their execution per time unit, that is your throughput. Next is turnaround time. Okay, the turnaround time is the time from submission till the end of the process, that is your turnaround time. Next is waiting time. Waiting time is how many time the process has been waiting in the ready queue. Next is your response time. Response time is okay, response time is when you have a call and the time when you get an answer for it. Okay, so that is your response time. Okay, so these are the criterias. So these are your scheduling criterias. Next is your performance criteria. We have to make sure we maximize CPU utilization and throughput and minimize turnaround time, waiting time and response time.